Hello everyone and welcome to this brief overview of correlation. So what is correlation? Correlation is a relationship between variables. By looking at a correlation, we can get an idea of how strong this relationship is and what type of relationship exists between our variables, so more about the direction. One feature of a correlation is, of course, its direction. By looking at whether or not a correlation has a positive or negative sign, we can tell what is happening between the variables. Also, we can take a look at a graph of a correlation and quickly see what direction our correlation is in. For example, a positive correlation occurs when both variables are increasing or decreasing at the same time. Our data set will fall in an upward sloping direction when we have a positive correlation. So if we have a data set that has points that look like what I'm putting on here now, we can see that if we drew a line through this data, it is going in an upward sloping direction. What this tells us is that as our variable x increases, our variable y is also increasing. Okay? Now, a negative correlation is what exists when our variables are going in opposite directions, meaning that as one variable increases, the other decreases. This gives us a negative correlation. So in this case, our data set will fall in a downward sloping direction. So if we have a data set that looks like this, and we draw the line that best fits this data set, we can see that it is going down. Okay? Now, what this means is that as our values for x increase, as we move along the x-axis, our values for y are decreasing. They're going down. So we can see here that our variables are going in opposite direction. As one is increasing, in this case our x value, then y is decreasing. Now, if our data set doesn't seem to follow either one of these predictable patterns, then it may be described as having no correlation. No correlation means there is no discernible pattern that can be detected between the variables, meaning that no relationship exists. This can happen in two different cases. One, the first one I'll present here, is where our data set appears to be scattered, where it has no real pattern. So let's say, for example, we had a data set that looks like this. Now, if we drew a line through this, like we did for the positive and negative correlation, you could see we would really have a straight line. This would be the best fit here. If we ever see this type of data set, or we can draw a straight horizontal line, then that means that there's no real relationship between x and y. Another way that we could possibly have a no correlation is if we have something that is curvilinear, which means that maybe our data set looks like this. It seems to curve around. So if we drew a line, it would appear to be this way. And we could also do a data set that would go in the opposite direction as well. And what this means is that it's not a reliable linear relationship. We can see here that when x is really low, so in this case right here, or when it's really high, y is low. And we can see that drawing a best fit line through our data set here does not lead to a sloping line or signifying a direction. A positive correlation, again, is signified by a positive sign, and both of our variables are going in the same direction. This can be from 0 to positive 1. A negative correlation, again, means that our correlation is from 0 to negative 1, or has a negative sign, and our variables are going in opposite directions. No correlation will be close to 0, so it will have no sign, and it means there is no discernible relationship between the variables. Another feature of a correlation is its strength. The closer the number is to 1, regardless of the sign or the direction, whether it's positive or negative or has a positive or negative sign, the stronger the correlation is. Though we would have to look up the critical R, or correlation coefficient, which is affected by the sample size, to determine whether or not the correlation is large enough to be significant, we can get a basic idea of the strength by simply look at the correlation coefficient itself. we can see here that an R equal to plus or minus 0.8 or higher is typically referred to as a strong correlation. An R equal to plus or minus 0.5 to 0.8 is considered a medium correlation, while R of equal to plus or minus 0.4 or lower is usually referred to as a weak correlation. Now we can have this for any of the types of correlations, positive or negative, that we were talking about before. For example, a strong positive correlation would fit a straight line, or would be very close to that straight line. So, for example, very similar to what I had listed up at the top of the screen, if we had a data set that looked like this, where our best fit line would go right through the middle, of course that's supposed to be a straight line, then that would be a very strong positive correlation. The closer those dots or the points in our data set are to that line, the stronger the relationship. And the stronger our correlation, the greater that number will be to 1. Now we can see this especially in, let's say, a weak positive correlation. Now again, it's positive, so our data set will still go in maybe an upward sloping direction. But you can see here that our points are spread out more. They're not packed greatly around the line that we have here, or the best fitting line. So this would represent a weaker correlation. Overall, remember that correlations tell us about a relationship between variables, how strong that relationship is, and in what direction those variables are going. However, we cannot infer causality or say that one variable is impacting or affecting the other.